Hello. We're going to create a micro library from start to finish, everything that we need to get this library up and running. There are a few benefits to creating a micro library in particular. First, because it's so small, it's easy to reason about the code because there's not much there. Second, also because it's small, it's really easy to test because there's not that much code that needs to be tested anyway. And third, it's easy to reuse this code in other projects because you can simply npm install it and you're good to go. There are a few drawbacks to micro libraries though. Some people complain about how it makes managing these dependencies a little bit more tricky because you have so many of them. It makes versioning a little bit more tricky as well. But all in all, micro libraries are a good solution for many use cases, and so that's why we're building one now. Finally, even though we're technically building a micro library in this series, the principles that you learn in this series can apply to micro libraries or huge libraries alike. Our micro library is called Star Wars Names. We have a list of Star Wars names, about 100 here, and we're going to enable users to call into our library, get this whole list, or get a random item from this list with a simple public API. In this series, we're going to learn how to create a Git repository, host it on GitHub, create the library, publish it to NPM, create a full test suite for it using Karma, Mocha, and Chai, set up continuous integration, add ES6 or ES 2015 using Babel, integrate Webpack, and ultimately distribute this in a form that is consumable by both the browser and Node. Enjoy the series. So the first thing that we're going to want to do is create a GitHub repo for this library. We'll go to our browser and go to github.com. And if you don't have an account, you can sign up here. I do have an account, so I'll just sign in. And then we'll go ahead and create a new repository, and we'll call it Star Wars Names, just the name of our library. And we'll say get a random Star Wars name. And we'll go ahead and create the repository. I'm just going to go ahead and copy this to the clipboard, and we'll paste it in. It'll run several of those commands, and then we're ready to push. So just to explain what this actually does is it creates a new file called readme.md and adds Star Wars names to the top. And then it initializes a Git repository locally. We add the readme that we just created. We commit with a message first commit. We add the remote origin, so this repository, and then we push it to master, setting our upstream. So if I refresh the browser now we have our Star Wars names and we have the readme. So we're all ready to go with a GitHub repository, and this is where we're going to be hosting our code and pushing our code. So in review, you need to create a GitHub user, you create a new repository, and then you follow the instructions to push your code to that repository. And that's how you get started with GitHub. So now that we have our GitHub repo set up, let's go ahead and configure some things locally for our NPM to make publishing a little bit easier. Before I get started, one thing that you're going to need to make sure that you do is install Node. So if you just search for Node.js, you go to nodejs.org, you can install it here, follow those prompts. If you type in npm --version and you don't get a version printed out, then you need to install Node. If you do, then you're just fine. So let's go ahead and go to docs.npmjs.com. We'll go down to config, and here there are a ton of configuration options. We're interested in only a few of these. So we'll look for init, and here are the properties that we're interested in setting. So the init author name, email, URL, and license. To set these properties, we simply type npm set and then the name of the property. So init author name, and then type in your name. And we'll do the same for init author email and init author URL. And npm set init license is MIT. So let's go ahead and take a look at the npm rc file that was created for us. We have the author name, email, URL, and license. One other property that I recommend setting is the save exact property. Save exact tells npm that whenever it is saving a dependency to your package.json, it will use the exact version rather than a version range. And this protects you for when people don't follow semver properly, or if there's a mistake in a release. This makes upgrading your dependencies full of a lot fewer surprises. So we're going to configure this default as well. So npm set save exact to true. Okay, so now we have that save exact. The last thing that we need to do is we need to log in. If you don't have an npm account, then you need to sign up for one here at npmjs.com. I'm logged in, but if you go and you're not logged in, you don't have an account, you simply go to sign up and fill in this form. Then you can go to your terminal and run npm add user. It will prompt you for your username, your password, and your email. And this will be used to create your auth token in your npm RC, which I'm not going to show to you. Now that we have our npm configured, we can create our package.json using npm init. This will walk you through creating your package.json. It has some logical defaults, and we can follow through with this. So the name of our module, Star Wars Names, is just fine. The version 1.0.0, and our description will just say get random Star Wars names. The entry point is what is used when you require a module by its name, so Star Wars names. So if we said index.js is our entry point, then we need to create an index.js in our root directory. And when people require Star Wars names, that's the file that will be resolved for that require statement. We're going to actually put it into our source/index.js. And then our test command will leave blank because we'll add tests later. And we'll go ahead with the default for our Git repository. And we'll say random Star Wars for our keywords. And our license is defaulted to MIT. So let's go ahead and say yes. And if we look at our package.json, you'll notice we have our name, our version, description, our main pointing to source index.js. We don't have a test command yet. We'll fill that in later. The repository was filled in for us. The keywords were filled in. The author is pre-filled based off of our init defaults, and license likewise. And then our bugs and homepage are derived from the repository that we specified. Okay, so that is how you set up your npm locally and initialize your package. You simply sign up for an account on npm, set a couple of configuration properties to make creating this package.json a little easier, run npm init, and follow through the prompt. With our npm configured and our package.json created, we are ready to start writing this library. Now we need to create our main file for our library, and so we're going to create a source/index.js. So a file in a source directory called index.js, and this is where the main export for our library will live. So when we say module.exports as common JS syntax, this is the object that will be exported when people require our module. So we're going to have two public API points on our module. First we'll have all, and then random. And these properties will be used to interact with our module. So the idea is that we want to have our Star Wars names exported as part of the all, and then we'll have a function that you can call to get a random Star Wars name. I'm going to go ahead and move the Star Wars names into our source directory here. And then we're going to require those Star Wars names to get the object that we need. So we'll simply say var Star Wars names equals require relative path Star Wars names.json. And this will create a JavaScript object for us, and we can simply assign that to the all property. For random, we need to create a function that will get a random item from this array. Now, this is actually a solved problem. And so instead of taking some time to figure out how to write this properly and then making sure that I cover it with tests properly, I'm going to just use a micro library that has already done this. So we're going to say npm install -- save to save this dependency to our package.json. And then the dependency is called unique random array. So once that's installed, it will be added as a node module right here, and it will be added to our package.json as well because we have the -- save there, and it's added as a dependency. And because we earlier configured our npm to use save exact by default, we are saving the exact version here, and we won't be surprised when somebody accidentally releases a breaking change. So let's go ahead and use this module. So we'll say var unique random array equals require unique random array. And then all that we need to do is say unique random array and pass our array, and that will return us a function that we can call to get a random item from that array. So if we want to manually test this really quick, we can go into the node REPL, and we can say var lib equals require source / index.js, and now we can say lib.all, and there are all of our random names, and then we can say lib.random and invoke that over and over again, and we get a random Star Wars name every time. And so it looks like from our manual testing that our library is working like we want it to, and so we're ready to commit these changes that we have and push them up to GitHub. Before we do that, let's go ahead and review what we did. So first, we created our index.js file that had our library in it. We moved the Star Wars names to the source directory right next to it. We brought that in, we exported it an all object, and this is what's going to be used when people require our module. And then we also created a random property, and we're using a third-party library to accomplish this. We installed this by saying npm install -- save unique random array. Just as a pro tip, there's a shortcut for this. We can say npm i -- and that is the exact same as npm install -- save. You can also install multiple dependencies in a single command just by listing the dependencies here. By adding save, it saved our dependencies to our package.json, and because we have configured our npm to save exact by default, it saved our dependency with the exact version rather than having a caret or a tilde for our version. And this protects us from surprises when somebody accidentally pushes a breaking change or doesn't honor semver. And that is how you create your first library. Now that we have some work done locally, let's go ahead and commit this up to GitHub so that we can save our work. If we type in git status, we're going to have a couple of things in here. One of those is this node modules directory. It's not advisable to commit your node modules directory for several reasons. One of these is collaborating with other users. Another is messing up your Git history with a lot of unnecessary changes that you may or may not actually want in your Git history. And so we're going to use npm to make sure that we have our dependencies properly locally, and we will git ignore our node modules. So let's create a new file here called .gitignore, and this will tell Git to ignore certain directories or files in our project. So we can say node modules, and now if we say git status, that's no longer there, and now we have this git ignore file, which is just fine. What we need to do here, just as it illustrates for us, is we need to add these untracked files. So we'll say git add, and we'll just say -a, capital A, to add everything. Now if we say git status, it says we have a few new files, and we can commit these to our repository. So we'll simply say git commit, and then we'll add a message of adding the library. Now if we say git status, we have one commit ahead of our origin master, so we can git push, and that will update our origin master. So now if we go to our Star Wars names repository, we have a source directory, a git ignore, and a package.json, everything that we need for our library to actually be published and used by consumers. However, we don't want to force people to go to our repository, go to the source directory, open up the index, copy this, This isn't something that we want people to do. We want them to be able to install our library from npm. And so next we're going to publish this library to npm. In review, all that we needed to do was create a gitignore file that specified known modules as an ignored directory. Then we said git add to add the untracked files, the new files that we created. And then we have a git commit to commit these files to our repository. And finally, we push these up to the GitHub repository. So now we're finally ready to publish our node module. We've already configured everything locally with npm in a previous lesson, as well as in our packagejson with this metadata. So all that really needs to happen is to simply run npm publish. So this will go out to npm, register our module in the registry, and then create the Star Wars names module. So now we can run npm info Star Wars names. You'll notice this looks similar to our packagejson. So this allows us to install our 1.0.0 version. So let's go ahead and test this out a little bit. Let's just change our directory to the desktop, and then we'll run npm install Star Wars names. This will install our module and our module's dependencies. Now we can create a file that uses our Star Wars names. So we'll say vim index.js, and we'll insert a Star Wars names require Star Wars names, and then we'll console.log Star Wars names.all, and then we'll console.log Star Wars names.random, and we'll do that a few times. Now if we say node index.js, we get all of those printed, and then our random items printed as well. If we run it again, the random ones are different every time. So it looks like we successfully published our first package to npm. If we go to the npm registry, we can shortcut to our module name with npm.im/starwarsnames. And this will take us to our registry item. Here we have Star Wars names, get random Star Wars names, and our readme could use a little bit of help. But it has a link to our Star Wars names. It has our license here. It lists me as a collaborator, and other information about our module, such as our dependencies. And that is publishing your first module to npm. In review, all that you need to do is run npm publish. As long as you've configured your npm with your user, then you should be all set. One other important aspect of releasing a package onto npm is to associate the version that you have on npm with your GitHub repository. You accomplish this by adding a version tag to your GitHub repository. A tag in Git is just something that points to a particular commit so that you can easily go back to that commit that is associated with a release of some kind or some other important aspect of your Git history. So to do this, you simply type git tag and then the name of the tag, and this was version 1.0.0, and so that will be the name of our tag. And now we can say git push -- tags to push our tags, and that will go up to GitHub. And so now if we look at GitHub, we'll refresh here, and we can see the tags here. We have a 1.0.0. And so now forever, this tag is associated to this release. And so if somebody needs to come and look at the implementation of this release or any other random reason, we have this associated. GitHub will also consider this tag as a release, and it follows a convention, and so somebody can come and look at all of the releases for our GitHub repository. You can also even draft a new release here with this specific tag, and that tag is existing. You can give it a title, super awesome initial release, and we can describe it. This is the first one, and let's give it some sparkles. And we can associate this as a pre-release. We can attach binaries, and we'll just go ahead and publish this release. And there we go. We've released our npm module onto npm, and then we've also associated that with a release on our GitHub repo. In review, to do this, all you need to do is type git tag and then the version, and then you push that up with the -- tags, and then on GitHub, you'll have that tag in your tags here, and you go to releases, draft new release, and fill out this form with the tag version that you specified. And that's how you release to both npm and GitHub. In this lesson, we're going to talk about pushing an update to our library. So let's say that in our Star Wars names JSON, we want to add Anakin's mother's name. So her name is Shmi Skywalker. And now we need to publish this out so people will start getting Shmi Skywalker as they get random Star Wars names. To accomplish this, we need to update our packagejson, and we need to bump up the version. And if you read into semver, you'll learn that each one of these numbers has a very important meaning to computers. So the first number represents a major version. That is bumped whenever you have a major release, being a breaking change of some kind. So for example, if we were to change the name of this from all to get all, that would be a breaking change and therefore would require a major version change, so that we would change that to 2. But our API is staying the same, so we don't need to bump that one. The second number represents a minor release, and so minor releases are associated to new features, but no breaking API changes. And so our API is remaining the same. We are adding a new feature, being a new person in our list of names. And so in our case, we would bump this version, so we'll just bump it up to 1. The last number is for a patch release. So this is a bug fix. So let's say that for some reason we had a problem in our unique random array implementation. There was something wrong there. If we fixed a bug there, then that would be grounds for updating the patch version. But we're adding a new feature, so we'll bump that version. And now let's just do a git status, make sure we've changed the things that we're expecting, a git diff, and we see those are the only 2 things that we've changed. So if we git add everything that we have modified, and we check our status, we have those 2 things staged. So now we'll go ahead and do a git commit with a message updating Star Wars names, adding Shmi Skywalker. Okay, so now let's go ahead and we'll do our tag for the GitHub portion of this. So 1.1.0, and then we'll do git push. So we'll push up the changed commits, and then we'll git push our tags to push up the tag, and then we'll run npm publish, and we'll publish the new version. And as soon as that's finished, we can run npm info Star Wars names. And if we look at the available versions here, we see 1.1.0, and that's the latest. And that is how you push an update. In review, you simply make the update, then you update the version according to semantic versioning. And so we updated the minor version because we're adding a new feature, a new name. And then you commit that code, you add a tag to that commit, you push that to GitHub, you push the tags to GitHub, and then you run npm publish, and that will publish the new version. And that is how you push a new version to your library. Now let's say we want to publish a beta version of our library. The way that we accomplish this is pretty much the same as if we were publishing anything. So let's go ahead and make the change. I'm going to go ahead and add Kent C. Dodds here, but I want to push this out as a beta because I'm not sure if people would be happy to have my name in here. And so I'd like to have people test it out, but not have it be the default version that's installed. So we'll go into our package.json, and on the version, we're going to bump it just as if it were a normal release. So this is a new feature. We'll bump the minor version, and then we're going to add a -beta.0 to the end of this. And so we can increment that 0 as much as we like, but this beta in the version indicates that this is a beta version. And so user beware. And so now let's go ahead and check out the diff. So these are the only things that we want to change. So we'll add all the changes and we'll commit those, adding Kent C dodds. And then we are going to git tag that commit with 1.4.0-beta.0. We'll push those commits up to GitHub. Then we'll push the tags. And then we'll still do an npm publish, but we will add the tag beta. And so we push that up. And when that's finished, if we run npm info, we can see all the information about the versions here. So we have our beta version there. And our latest is still pointing to the solid version of 1.3.0, but our beta version, or our beta tag, is pointed to 1.4.0. And so now if we change our directory to the desktop, and if I run npm install Star Wars names, then we'll see that we install 1.3.0. But if I'm living on the edge and I say npm install Star Wars names at beta, then this will give me the 1.4.0/beta. And then obviously I can also just install the specific version, so 1.4.0 beta 0. And that will allow me to install that specific version. But using the beta, we'll install the latest beta tagged version. And so that is how you release a beta version. And when we're ready to go with the next version, we simply remove this beta and we publish the new version without the tag, and we're good to go. So in review, to publish a beta version, you simply make all of the changes that you would for a regular release, whatever it is that you want to release in the beta version. And then instead of just a simple version bump, you do the normal version bump that you would. In our case, we bumped the minor version because it's a new feature. And then you add the -beta and .0, and this is what you will increment as you iterate on your beta versions. And then you commit your changes, you add a tag with the same version, and then you push those up to GitHub, and then you run npm publish -- tag and then beta, and that will push it with the beta tag. And then when users install, if they aren't aware of your beta versions or they don't want it, they simply get the latest stable version, and then users can install the beta version if they so desire. All right, so it's definitely time that we start adding some tests to this, because this library is like serious and we don't want to push any breaking changes on accident. So we're going to use Mocha and Chai to do our testing for this library. So let's npm install Mocha and Chai, and we'll save these as dev dependencies. So save dev. And pro tip, you can actually do a shortcut here. So npm i-D is the same as npm install -- save dev. And once we have those dependencies in here, you'll see that they're added as dev dependencies in our package.json. And so we have Chai and Mocha. They're added in our node modules directory. And now we can go into our source. We'll add a new file called index.test.js. And in here, we'll say var Star Wars equals require index. And we'll also say var expect equals require chai.expect. And then we'll use the global describe from Mocha. We'll describe Star Wars names, and we'll do a simple assertion, it should work, and we'll say expect true to be true, just as a simple assertion to make sure that our tests are running. So we'll go to our package.json now, and we'll finally be able to update our test script. So here we'll say Mocha, and then we'll point it to source index.test.js, and we'll add -w so that it watches the file system for changes. And so now if we run npm test, it works. And that is how you set up your system to start testing with Mocha and Chai, is you add them to your dev dependencies by running npm install -d Mocha Chai, and those will be added to your dev dependencies as well as installed into your node modules. Then you create your test file, you require Chai and we're going to pull off expect off of chai. We have our node module here as well, and then we just simply use the global describe and it from mocha so that we can describe our tests and make our assertions with expect. And then we update our scripts so that test is using mocha, and so when we run npm test, it runs our mocha tests. And that is how you set up mocha and chai for testing your library. And now that we have mocha and chai set up, we can actually start testing our library. So let's go ahead and add some sensible assertions and descriptions. So if we look at the API to our module, we have two parts of our API, all and random. So we want to validate that all is an array of strings, and maybe there's a specific name that we want to validate, and then we want to validate that random returns a random item from that array. So let's start off with all. So we'll describe all, and it should be an array of strings. And so we'll expect that star_wars.all to satisfy is array of strings, and then we'll create that is array of strings function, and that takes an array, and we'll just simply return array.every item return type of item string. And so now if we run npm test, and pro tip, you can run npm t, and that's a shortcut. And so it is an array of strings. Now let's just validate to not satisfy, and so it fails. So we know that this test is actually running and it's validating what we expect. The next thing is maybe we want to validate that we will never actually remove Luke Skywalker from that list of Star Wars names. So it should contain Luke Skywalker. So we'll expect star_wars.all to include Luke Skywalker. And that is passing. Let's just validate ourselves. It doesn't include Luke Skywalker's, and so this test is actually running and it's working. The next part of our API to validate is the random. And so we'll describe random, and it should return a random item from the star_wars.all. Now we'll say var random item equals star_wars.random, and then we'll expect star_wars.all to include random item. We save that. It looks good. To not include, we get it an error thrown. So looks like that test is running and passing. And now we have full code coverage over our very, very small library. And we're verifying some of the things that we want to make sure don't break. And that is how you test with Mocha and Chai. To review, you simply use the global describe function and it function to describe your tests and what they should do. And then you list your assertions using Chai's expect. So there are a couple of repeated steps when releasing a new version of a library. First, you have to develop the new feature or the bug fix, and then you have to commit that, and you have to tag that commit, and you have to publish it, and you push it up to GitHub. So there are a lot of different steps, and it's as programmers, we don't like to repeat ourselves. And so there's a tool that was developed called semanticrelease that makes releasing new versions of your software super, super easy. And so we're going to do that now with our library Star Wars names. So we'll run npm install -g semanticrelease CLI. Now with that installed, let's go ahead and run semanticrelease CLI setup. And this is going to take us through a prompt. So our GitHub repository is not private. With the capital N there, that's the default, so we'll just hit enter. And then our npm repository or registry is just the normal one, so I'll go with the default there. It read my npm username and my npm email. It got my GitHub username. And now I'm going to choose what continuous integration service I'm using. So the way that semantic release works is it will actually release your software or your library during continuous integration. We haven't set up any continuous integration, but semantic release will actually set it up for us and will initialize things for us. And so we're going to stick with travisci. If you don't want to use travisci, you want to use snap or CodeShip or something else, then you can just print the tokens and then you can use those and set those in your continuous integration. But we'll go ahead and stick with travisci. What semantic release is doing is it's creating a Travis job for our library and adding a couple of things to our project. So for us, we're just going to stick with a single node version in our Travis YAML. And now let's go ahead and look at our project. So there are a couple of new things in here. First, you'll see the Travis YAML is new. We'll look at that in a moment. And then you also have packagejson. Let's go ahead and look at some of the changes here. The first thing you'll notice is we have a new, we've removed the version from our packagejson. And this isn't really that big of a deal because when we actually release, then Travis will do the releasing and semantic release will actually add the version to our packagejson right before it releases. And so we don't have to worry about what version our library is in. We just, using some conventions with our commit messages, specify the types of changes that we're making, and then semantic release is able to determine the version based off of the changes that are in our Git history. I'm going to actually restore the version and just set it to 0.0.0 and say it's semantically released. And the reason that I'm doing that is when I run npm install, npm will give me a warning if my package doesn't have a version. And so I'm putting that back in there. And then with scripts, it's adding a script semantic release, and it's calling semantic release pre, and then it is doing the npm publish for us, and then semantic release post. And it does, semantic release does a lot of magic under the covers to make sure that things are ready for when this npm publish happens, like setting the version properly. It's also updating our URL to be a HTTPS URL. And it's adding the semantic release dependency to our dev dependencies. And now let's go ahead and take a look at the Travis YAML. So it's specifying we don't need sudo. It's specifying our language, setting up the cache so we don't install our node modules over and over again. We don't need a notification, or we can set that up if we want to. And then it's saying before install, go ahead and install the latest version of npm at 2.0. And before we run our script, we'll npm prune. And then after we run our script, after our script is successful, then we run the semantic release script that semantic release created for us here. And so now we're going to go ahead and configure Travis to make sure that we run the build before we actually release. So we don't want to do any sort of releasing before we verify that our tests are working. So let's go ahead and add a script here with npm run test. And so now our tests will run, and if they fail, then this after success will never run and we won't release a new version. However, if they do succeed, then we will release a new version, and semantic release will find out what version it should be based off of our Git commits. And we'll talk about that in the next lesson. So just to review, what you need to do is you run npm install -g globally, semantic release CLI, and then setup. And that will take you through this prompt here. And it will, depending on what CI you decide to use, it will create a Travis YAML if you choose Travis. And here we have the Travis YAML here. We added this script here to make sure that we are running our test so we don't push out a new release if our tests are breaking. And semantic release added this script, which it's using in the after success. And that is how you set up your repository to be released with semantic release. Now that we have our semantic release all set up, we need to start following the conventions that semantic release uses to determine what version to bump. These conventions are the same conventions that Angular uses to update its changelog automatically. So let's go ahead and look at those. Here in the Angular contributing document, we can see that they have these commit guidelines and a very specific commit message format. You have your header, a blank line, then body, a blank line, and then footer. So the type here is how semantic release knows whether to update your minor version if you specify a feature, or a patch version if you specify a fix. And then if you have a breaking change, then those are specified in the footer as breaking change. And so you can read over this convention, and it's pretty strict. And so to make this a little bit easier, we have a tool called commitizen that makes creating these commit messages much easier. So let's go ahead and install that now. We'll run npm install as dev dependencies commitizen and cz conventional changelog. Commitizen is going to allow us to write these commit messages, and then the cz conventional changelog is going to ask us the questions to actually generate this commit message. So if we look at our package.json, we've added cz conventional changelog and commitizen adds a binary to our node modules directory called getcz. And so we can access this binary in our scripts. And so that's exactly what we'll do. We'll create a script called commit, and we'll just simply reference getcz. And then we need to tell getcz that it needs to use the cz conventional changelog. To do this, we say in our package.json cz config, and then we specify the path is node modules / cz conventional changelog. Now with this in place, if we look at our status, we have a new file and a modified file. Let's go ahead and add everything. So let's expand this out a little bit, and we'll run our first commit message. Let's make sure that we've staged everything that we want to have committed in this commit, and then we can run npm run commit. Now it will prompt us for the different sections of our conventional changelog convention that we're following. And so for us, the changes that we're adding are related to the build. So I'm going to mark that as a chore. And we'll simply say this is part of the build, or maybe releasing. And we write our description, add travis config, conventional commit, and semantic release. So a longer description of this change we can omit. And any issues or breaking changes, if there were any, we'd say closes number 4. And in fact, let's go ahead and do this right now. We'll go into our Star Wars name repository. We'll create a new issue, simplify releases with semantic release and commitizen. We'll submit that new issue. And then this is issue number 1. So we'll say it closes number 1. And if there were any breaking changes, then we would add those there. So our commit succeeded. If we do a git log, then we can see we have a chore releasing add travis config conventional commit. If we'd added a body, it would appear here. And then we say that it closes number 1. So that is setting up commitizen with your project. Let's go ahead and review. What you need to do is you run npm install commitizen and cz conventional changelog. Then you configure commitizen with cz config and specify a path to the conventional changelog. Then we also added a script here for commit that just simply references the bin that commitizen gives us called getcz. And then we stage all of our changes and then run npm run commit to actually commit our code. And that's how you set up commitizen in your project to simplify creating the conventional commit messages that semantic release uses to release your library. Now let's go ahead and add a new feature, commit that, and see what happens with semantic release and that new feature. So let's go to our source directory, and we're going to add a new feature that will allow us to specify how many random names that we want. So let's go ahead and jump into our tests. And inside of our random describe, we'll say it should return an array of random items if passed a number. So our API will look something like this. We'll say var random items equals starwars.random3. And we'll expect random items to have length of 3. And then we'll go over the random items for each item. And we'll do the same assertion that we have up here, except instead of random item, it will simply be item. So now if we run npm test, we have a failing test here. Let's go ahead and develop this feature. So we'll pull this unique random array out into a variable called getRandomItem. And then instead of assigning random to getRandomItem, we're going to assign it to a function we'll create called random. And this function will take a number. That number will be optional, so we'll say if number is undefined, then we'll simply return getRandomItem, just as before. And so now it can't read property length of undefined. We need to add an else case. So we'll create a new array, random items, and we'll say for var I equals 0, I is less than number, and I plus plus, your standard for loop. And we'll say random items.push get random item, and then we'll return random items. We save and our tests are passing. So we're ready to go with this new feature. So I'll cancel this and I'll clear. And now, because we're using semantic release, we don't need to worry about updating the version here. In fact, we don't even need to worry about creating a changelog and documenting our changelog. All of the documentation happens inside of your commit messages. And so we're going to run this commit script. Let's expand this out a little bit and we'll say git status. We have two change files. We'll git add, and we have those ready to be committed. So now we'll run npm run commit rather than git commit. And this will take us through our prompts. We'll say this is a new feature. The scope is the random function, and we'll write a quick description, and we'll provide a body. And we actually have an issue on GitHub for this feature. It's issue number 2, and we can reference that in our commit message. So we'll say closes number 2. And if we had any breaking changes, we would add that as a breaking change and define our breaking change, but we don't need to do that. And our commit succeeded. If we look at our git log, we'll see we have our feature for random, our subject, and our body, and our footer. So that's how you add a new feature using the conventional commit style. And so now when we push up to our GitHub repository, our Travis build will run, and semantic release will know that it needs to release a new minor version because of this new feature. And that's what we'll talk about next. It's the moment you've all been waiting for. We are going to push our code to GitHub. And because semantic release set up a Travis build for us, we're going to look at what that Travis build looks like, and we'll see that semantic release releases a new version of our library for us automatically based off of our commit messages. Just in review, we'll look at the git log to see we have 2 commits that haven't been pushed to master. They're both following the convention that we need to, so that semantic release knows what version to push out to npm. And if we just look at our git status, we don't have any remaining commits locally, but we're ahead by origin master with 2 commits. So let's go ahead and push these to master. So while that's running, we see that one of those commits closed this issue, and we can see the other commit closed the simplify releases issue. So now we can go to our Travis build, which we didn't have to set up. Semantic release did that for us. So we'll go to travisci.org. We'll go to our repo, Star Wars names. We'll see that this has been set up for us. It's already running. It's running our npm install right now. This is our first build, and we'll go ahead and let this run. We'll follow the log as we go. It's run our tests, and it looks like we have a problem. If we look back at our packagejson, our test adds this -w here. And so let's go ahead and add another script called test single, which removes the -w, so it only runs once. And then in our Travis, instead of running test, we'll run test single. And let's go ahead and commit that, following our commit strategy. But before we do this, let's cancel this build, because we're going to build another one. So we'll get status, we'll get add everything, and then we'll run npm run commit. And let's expand this out a little bit. So this is a chore related to the build. Add our subject, and we'll add a longer description, and we don't have any issues related to this. Now we'll push this, that gets pushed up, and Travis will automatically run this build for us. If we want to jump ahead, we'll look at our build history and jump right to that build. It'll take a moment before it actually starts. It started. Now let's follow the log. Our dependencies have been installed. Now it's running our tests. It exited with 0. Now it's running semanticrelease, which will publish our new version to npm. It looks like it has been published as 1.5.0, which makes sense because before it was 1.4. Now let's go see at all of the things that semanticrelease did for us automatically. If we go back to our GitHub repository, we'll go to releases, and we have this 1.5 release. It has our feature based off of our commit. It references the issue that it closed, and it has a link to the actual commit. Now if we go to our package on npm, we'll see that 1.5.0 is the latest of 9 releases, and it was published a minute ago. All of this was done magically for us by semanticrelease and our build process. We didn't have to decide, is this a minor or a major? And we didn't have to worry about creating our changelog in our releases. All of this just happened magically for us because of semanticrelease and us following a couple conventions in our git commit messages using commitizen. Now that we have everything set up with travisci, we are ensuring that we're not releasing anything that breaks the tests. But one thing that would be really nice is to not actually forget to run the tests before we send it off to travisci to have it run. Make sure we get a tight feedback loop. And so one really awesome feature about Git is called Git hooks. And you have different places where you can hook into Git and execute some script before or after a certain action. And so what we'd like to do is run our tests before we can actually commit any code. Make sure that we're not committing anything that could break. And so we're going to do this by using something called ghooks. One thing about Git hooks is that they're not actually committed to source. And so if we set up a Git hook locally and then somebody else clones our project, they won't have the same Git hooks that we have. And so ghooks actually makes it so when you npm install, it will install the Git hooks, and you can define your Git hooks in your packagejson. So let's go ahead and install ghooks. npm id ghooks. And now we can look in our packagejson, and we'll see ghooks is installed there. To configure ghooks, we add this config object with ghooks, and we'll say pre-commit, and we'll simply run our test single script. So we'll npm run test single. And so let's go ahead and break our test and see ghooks protecting us there. So if I change this to a 1, for example, and then I run git commit all the things, it's going to run our tests, and because our tests fail, we can't actually commit. So let's go ahead and fix our test. And this npm debug came from the fact that our npm script failed. So let's go ahead and remove that. And if we look at our git status, make sure that we're only modifying the packagejson. So we'll look at the diff. So we have the ghooks config, ghooks. So let's go ahead and add everything. Look at our git status again. And let's run npm run commit. This is a chore. It's related to ghooks. Add ghooks and our description, and we don't have any issues. Ghooks will run the test for us. If they pass, then our commit succeeds, and we can push this up to our remote repository. If we look at our build, we see ghooks, add ghooks, protect ourselves, as I said, and it will run our build. Everything should pass just fine, and now we're protected because of ghooks. So in review, all that you need to do is npm install -d ghooks, and that will add ghooks to your dev dependencies. And then you configure ghooks via the config ghooks, and then any of the git hooks that you want to have run. To add coverage to our library, we're going to use a tool called Istanbul, which will instrument our code so that coverage can be recorded and reported. So we'll install as a dev dependency Istanbul, and then we'll look at our packagejson. We'll see that Istanbul has been added to our dev dependencies, and we need to make some alterations to our test scripts so that Istanbul can instrument our code for coverage reporting. We'll do our test single one here first. So what we're going to change is first we need to run the Istanbul command instead of the mocha command. So we'll say Istanbul cover, and then we want to exclude our index.test.js because that's a test file. We don't want to report coverage stats on that. So we'll exclude anything that ends in .test.js, and then we're going to actually run the _mocha command, and this is in our bin as _mocha, and this is what Istanbul needs us to run for us to get coverage using the mocha framework. Now we need to pass some arguments to the mocha command, such as the file that we want to pass, and we do this by specifying this double dash, and then everything after here will be passed down into the binary that we're using to run our tests. So we're passing our source test file, and to get the coverage stats, we need to change our reporter to be spec. So we'll save that, and then we'll npm run test single. This will run our tests. We'll get the output in our console the same, but in addition, we'll get this coverage summary. We have 100% coverage. Let's go ahead and take a look at this file that was created as well. So there's a coverage directory, has a coverage JSON and lcov info. It also has this lcov report that we can open in our browser. So let's go ahead and open that, and we can browse our files, our source code, and see how many times each line was hit in our test. So it looks like we hit this line 3 times, and that makes sense because we call that function one time with a number, and that number just happens to be 3. So it iterates over that function 3 times. In review, you simply install Istanbul, and then you say Istanbul cover, you exclude your test files so you only cover your actual source. You change the mocha to an _mocha, and then you add the rspec reporter as an argument to the _mocha binary. One final thing that we'll want to make sure that we do is we don't want to commit this coverage folder to our source code. So if we look at the git status, we'll see coverage is there, but it's not a tracked file. We want to make sure that it's not ever tracked. So we'll go to our git ignore, and we'll simply add coverage in here so that that directory is ignored. Now if we look at the git status, we see that only the change files were added. Now that we have coverage reporting, we want to make sure that our coverage doesn't drop below a certain level. If we run npm run test single so that we get our coverage reporting, we'll see that we have 100% coverage on statements, branches, functions, and lines. That's awesome, and it's actually quite easy to accomplish in such a small library. But in bigger libraries or in projects, it's a little bit more difficult to get that kind of coverage, and so having a standard that you can't drop below is a really good thing. And as we add features to our Star Wars name library, we're going to want to make sure that we don't drop in coverage, but that we always test the new features that come in. So let's go ahead and add a git hook using the ghooks that we installed earlier for our pre-commit to make sure that we don't drop in coverage. We're going to add a new script, and I'll just enter it in here now, npm run check coverage. And then let's go ahead and go to our scripts, and we'll add a check coverage script. And this one will simply be Istanbul check coverage. And this is where we'll specify what levels our coverage should be at. So for statements, we want it to be 100%. For branches, we want 100%. For functions, we want 100%. And for lines, we want 100%. So now if we run npm run check coverage, then it will succeed if there's nothing wrong with our coverage. Let's go ahead and drop our coverage a little bit. If I add a random function in here, do something, and we console.log hi, our tests aren't running this, our code isn't running this, so this function won't be covered. Now if I run npm run test single to get our coverage reporting, you'll see that our functions are down to 50%. Now if we run npm run check coverage, we're going to get a big error, and it will explain that our coverage isn't to the standard that we've specified. And so because this is part of our pre-commit Git hook, we won't be able to commit to our code anything that drops below our coverage standard, which in our case with this small library is 100% across the board. And that is how you add coverage checking to your library. And so because we have this now, we want to actually add this to our Travis so that not only will the test run, but we make sure that we have everything covered and before we release any new version. So we'll have npm run check coverage, and that will be part of our Travis build. In review, all that we need to do is we create a script called check coverage. We use Istanbul's built-in check coverage functionality, and we specify our standard for statements, branches, functions, and lines. And then we also added the check coverage command to our pre-commit Git hooks, and so nobody can commit coverage that is below our standard. And in the case that something ever does happen, we have this in our Travis as well to make sure that we don't release anything that is below our coverage standard. And that's how you add coverage checking to your library. Now that we have coverage reporting going in our project, we want to actually send these reports to a third-party service so that we can have one of those cool badges on our project that says we have 100% coverage, and we can also browse our coverage in our project. So we're going to use a service called CodeCove. If we go to codecove.io, you'll want to sign up for an account and log in. And then let's just go to codecove.io/github/kentcdodds/Star Wars names. And this will indicate that we have no reports uploaded, but it will give us an upload token, which I will hide so you can't see. But you'll notice that this upload token is actually not required on Travis because there's an integration there. So adding this integration with CodeCove will be really easy. All that we need to do is npm install -d as a dev dependency codecove.io, and then we'll go into our packagejson. We'll see that codecove.io has been added, and we're going to take one of the coverage stats here, and we're going to pipe it into the codecove binary. So let's look into our node modules. In the .bin, we have a codecove binary that we can use in our npm scripts. Let's make a new script called report coverage, and we will simply cat our coverage/lcov.info, and we'll pipe that into codecove. And we want this to run on Travis, so after our success, we'll run npm run report coverage. So the test single will create the coverage, then we'll check that our coverage is up to standard, and then we'll report the coverage to codecove so that we can have that reporting and history of our coverage. So if we look at our Git status, we have these modified files. Let's add them. Make sure that they're there. And now we'll run our npm run commit. We'll expand this. We'll say that this is a chore related to tests. Add reporting to codecove. We'll add a description. And we don't have any issues on here. So it's running our test, making sure our coverage is up to snuff. And then we'll git push those changes. Now let's go ahead and take a look at our Travis. And here in just a moment, it will start our new build. It's starting our build. We'll follow the log. And it fails. But the failure is from semantic release. This is after the success of our build. And it's just simply semantic release saying there are no new changes that are necessary to be released because this was simply a chore. So our build passed. Now if we look at CodeCove and we refresh, we'll see that we have our reporting stats in here, which is really handy. One of the things that I really like about CodeCove is they have a Chrome extension that you can install. And if we refresh, we'll get our coverage reporting in here. And so we can toggle that reporting on. And if we didn't have 100% coverage, then we would see some red lines in here. So it's integrated with GitHub, which is really nice. So that's how you report coverage statistics to CodeCove. In review, you simply install CodeCove as a dev dependency. You add a report coverage script to your npm scripts, which will cat the lcov info file to CodeCove. And then you add this report coverage to your after success to actually report the coverage. Now that we have a build and coverage reporting and our library is published to npm, we'd like to add some badges to our readme so that people know the status of our project. And right now our readme is looking pretty sad, and this would be a good opportunity to actually document the API of our readme. But we're going to just add badges to our readme so people can keep up with the status. So there is a really cool site called shields.io. And here it has badges for a lot of different services. And so we're going to get all of our badges from this service. So first we're going to get Travis for our build. So we'll copy this and we'll get into our README. And we're going to put this in our markdown as an image. So this is the syntax for an image. We'll have a couple of these. This is the description. So Travis build. And this is the link to the image. So this is for Node. If we go to that URL, we'll see the build is failing for Node apparently. But if we change it to the Star Wars names, then we see the build is passing. And also, I actually prefer the flat style. So flat squared. So we'll say style is flat square. And that is what we'll use for our URL. Now we have the badge in our README, but we want to actually have the badge be linked to our build. And so we're going to take this icon image and we'll make that a link in itself. And so now whatever we put into here will be the URL. We want to link to our build, which is right here. So we'll just put that in there. And so now we have a badge for Travis. Let's go ahead and add one for CodeCove and a couple for NPM, information about NPM, and link to those as well. So there we have all the badges that we're going to include in this README. There are a ton more that you can add from Shields.io, and many services will have their own badges as well. And it's very simple. You simply add the image annotation there with the name of the image and a link to the image, and then you can turn that into a link by simply surrounding it by the brackets and then putting your link in here. And that's adding badges to your README. If we want to write our code using the latest features of the JavaScript language, we're going to need a transpiler because the platforms that we're delivering to, whether it be the browser or Node, will not necessarily support all the features that we'll be using. The transpiler we're going to use is called Babel. We're going to use the Babel CLI to transpile using one of our npm scripts. So we're going to run npm install save dev, or pro tip npm i-d babel-cli. With that installed, we can see it in our dev dependencies here. We can now add a build script. So we'll say build, and in here we'll use the Babel CLI that has been added to our node modules bin. We can see Babel there. So here we can use Babel, and we want our outdir, the directory for the transpiled files, to be the dist directory, which Babel will create for us. And then our input directory will be the source directory. So let's go ahead and run npm run build. It's going to run our files through Babel and output those in our dist directory. However, we see that we have this index.test.js file in here, and we don't want to distribute our test. There's really no reason to do that. And so we're going to add ignore star.test.js. This will tell Babel to not worry about anything that has .test in it. Now if we run npm run build, we're going to see that the index.test.js file is still in the dist directory. Now this is simple enough to solve because we can just go ahead and delete that dist directory, and then we can rerun npm run build, and we'll see that the test file is no longer in there, and so that's just fine. However, as we build this library and add different files to it, we don't want to have to always remember to remove the dist directory, and so we're going to have another step in our build process to delete the dist directory before we run the build. Essentially, we want to run something before the build script runs, and this is accomplished by simply adding pre and then the name of the other script. So what I can do here is run rm-rf dist, and now if I run the build, npm run build, it's going to first delete the dist directory and then recreate it, and we can verify that by adding a foo.js in here. And if I rerun that, it deletes everything and recreates the dist directory. However, this is not cross-platform. rm-rf will only run on Unix-based machines like Mac. And so because I want this to be run on Windows for contributors who might be coming from Windows, I need to come up with a cross-platform solution. And there's a package I can use to do this. Well, npm install as a dev dependency rim-raf. And this package will basically allow me the same kind of API that I can use. We can see that it's been installed as a dev dependency here. And so I can replace rm-rf with rim-raf. And this is now cross-platform. So now that we have our build running, let's go ahead and add some ES6 in our source. So we'll convert these require statements into ES6 imports. Save that, and now we'll run our build, npm run build. And let's take a look at our output. Oh dear, we need to actually transpile something, and even though we're running things through Babel, we're not actually getting any transpilation. And this is where transforms and presets come into play. By default, Babel doesn't actually do anything to your code. You need to explicitly list the transforms that you want to have Babel apply to your code. However, managing this list of transforms would be really tedious, and so Babel has this concept of presets that include a bunch of transforms, and we're going to use some of those now. So we're installing the ES 2015 preset, which includes all of the features available in ES 2015, as well as the Stage 2 preset, which includes all of the features that are currently at Stage 2 in the standards process. So if we look at our dev dependencies here, we'll see those installed. Now we need to configure Babel to use these presets on our code that it's transpiling. There are a couple of ways that you can do this. We're going to go ahead and add it right in our packagejson. And with that, if we now run npm run build and check out our dist, we're going to see that Babel is indeed transpiling our import statements. Now we need to go to our packagejson and update the main to point to this new dist file so that when people require Star Wars names, they're going to be getting the transpiled version rather than the ES6 version. And then we'll see that we have another problem. You see, if we look at our index.js here, we are doing this simple require Star Wars names JSON. However, in our dist directory, there is no Star Wars names JSON. And so we need to copy this file over into the dist directory. Babel actually includes this feature as part of its CLI, and so we can simply add --copy--files and save that. Now if we rerun the build, we'll see that the Star Wars names is now included. There are still actually a few more things that we need to make sure of. First off, we need to make sure that before we run this publish script, we're going to run the build script. Now you might think that you can do the same thing to the publish script as we do to the build script. However, this pre-published script actually runs when people install our module inexplicably, and so we want to avoid doing that. We'll simply add this to our Travis build. So right after we run the tests, we'll run npm run build, and this will run before we do our semantic release, and so we'll be actually releasing the built version of our library. Now that we have everything ready to be built and then published to the registry, let's make sure that what is actually published to the registry is what we're expecting. We can test this out by running npm pack. This will create an archive file that we can open and then explore. If we look in package, we now see npm ignore, Travis YAML, packagejson, source. We see a lot of things that we probably don't need to actually distribute with our module. So we can scope these things down in our packagejson by adding a files property that's an array of the files we want to have actually included. The only ones that really matter is the dist directory and probably the readme. Now if we get rid of these files here and then rerun npm pack and open that archive file, we can see that the package now only contains the dist directory with our main file and the Star Wars names JSON file, a packagejson, and our readme. Now, one final thing that we want to make sure that we do, let's go ahead and delete these files again. We definitely don't want to push those to Git. There's one other file we don't want to push to Git, and it's this dist directory. So we'll go ahead and add that to our git ignore, because that will be rebuilt every single time we run the build locally. We don't want to actually commit that. And so by adding it to our gitignore, that's not going to be committed to GitHub, but it will actually be included when we publish to the registry, as we saw with the npm pack. So to recap, to add ES6 support to your library, you simply need to install Babel CLI and the presets for the transforms that you want to include for your transpilation. And then you configure Babel. You can do this in the packagejson or as a Babel RC file, and you specify the presets there. And then we added a build script that used Babel CLI to transpile our files in the source directory to the output directory of dist. We wanted to ignore our tests. We wanted to copy the files over. And then as a pre-build step, we added rimraf as a dependency and deleted the dist directory every time when we run the build. We changed the main to point to the dist index.js, this new file that we're transpiling into. And then we also specified our files here to be a little bit more explicit about what it is that we're including in our package, specifically the dist directory being the thing that we're actually distributing. And finally, very important, in the Travis YAML, we specified that we run the build before we run our release to make sure that we are actually transpiling, and that is what we publish to the registry. And that's how you add ES6 support to your module. So we're really excited because we finally added ES6 support to our module, and now we go to run the tests, and we see that there is a bit of a problem. Istanbul and Mocha can't deal with ES6 very well, specifically this import statement. So we need to add ES6 support to our tests. That's what we're going to do. To get started, we're first going to install as a dev dependency nyc, which handles ES6 for code coverage a little bit better than Istanbul. It actually uses Istanbul under the hood, but it handles the ES6 syntax for us. Let's go ahead and change out Istanbul for nyc for right now. We're still not done though. Mocha doesn't understand ES6 either, and we need to make sure that Mocha can run our tests even when they're written in ES6. To do this, we're going to leverage the compilers flag, and for JS files, we want to use the Babel register compiler. This is another dependency we'll need to install. And now if we run npm run watch test, we'll expand this a bit, we'll see that our tests are now running. Let's see what this looks like with coverage. Before that, we need to make sure that we add the compilers to our coverage script. And now we can run npm run test or npm test or npmt. All three of those are the same. We'll see that this failed. And the reason that this failed is because nyc's API is a little bit different. So let's go ahead and make a couple of changes here. nyc actually has a really nice API. So we're going to clean up our scripts a little bit to make it easier for nyc. First, we're going to add a cover script, which we'll use in a moment. And then we'll change our test script to actually simply be mocha src index.test.js compilers js babel register. And then because this looks an awful lot like our watch test, we can actually change our watch test to be npmt -w. So that's simply adding the -w flag to this script. So our watch test should still work if we run npm run watch test. And if you see, the script that it's actually executing is npmt -w, and then it ends up executing the full script that we want it to run in the first place. This is leveraging a feature from npm with that --. Any npm script that's run with a --, will have the additional arguments passed to the script that's being run. Here we'll simply say nyc and then npmt. Now, if we cancel this and run npm run cover, we'll see that we get our coverage report. We'll see that our tests all pass just fine, even though they're requiring files, even though our tests are using files that are written in ES6. It's working because we're leveraging the compilers flag from Mocha using Babel register, which is transpiling our files on the fly. We're not done though. There are a couple of things we need to update. First, our git hook here needs to change from the test to run cover, because we want to check the coverage on our git hook. And then also in Travis, we need to change test to cover here as well. So now let's go ahead and go into one of our test files, and we'll convert this to ES6 module syntax. And with that, if we run npm run cover, then everything should run just fine. It does. If we run npm run watch test, then we'll see that our tests are running and being watched as well. Finally, one other thing that we need to make sure we do is we'll see we have this nyc output. I'm not sure what nyc is doing with that, but we do not want to commit that to source control. So we'll add that to our gitignore, and we're good to go. In review, let's check out some of the things that we had to change. First, we had to change Istanbul for nyc. So we installed nyc right here, and we uninstalled Istanbul. And then we replaced Istanbul check coverage with nyc check coverage, which has the same API. But then we changed the test script to be just the base test script that we want. And then we leveraged that test script in both the cover and the watch test npm scripts. In the cover script, we simply added nyc and then npmt. And in the main base test script, we added this compilers to the JS files and used the Babel register compiler. Then we had to update our git hook to run the new cover script. We updated our travis YAML to run the cover script. And we updated our gitignore to ignore the nyc output folder that nyc creates for us. And then from there, we can start writing our tests in ES6 and importing things that are using ES6 syntax. If you look at the badges on our readme, we'll see that our build is failing. Let's go ahead and take a look at our build. What's actually failing is there was a problem with one of the lessons that I deployed, and that build failed. But it's showing up that our build is failing, and we don't really want that. The actual master build, the releases, those are all passing. And so what we're going to do is we're going to tell Travis that we only want to build specific branches, and we don't want to build any of the lesson branches or anything else. It'll be just specific branches that we explicitly mention. And so to do this, we are going to go ahead and jump into our travis.yaml file, and we'll add a branches here with an only, and we'll specify master. So we're only going to build master. Now Travis will automatically continue to build the pull requests, which is something that we definitely want, so that when somebody makes a pull request, we can see that their pull request will merge and that the build will continue to pass. But we only want to build our master branch. And then we could list other branches, and it actually takes regex here. And you can actually, this is a white list. You can do a black list with exclude, but we're just going to do a white list with only. And now all that we need to do is commit this change. So let's look at our git status. We have that modified file. Let's do git add and git status. And so now we can run npm run commit, and we'll go through our commitizen. This is a chore related to Travis, only build master and PRs, because we don't want to waste resources. Save the trees. And we'll go ahead and add a tree emoji. Probably a Christmas tree is good. And we don't have any issues related to this change, so we'll just skip that. And now that all of our commit hooks have passed and everything is worked out, our commit succeeded. Now we'll go ahead and push. And if we look at our Travis build at the current, here in a moment, it will update to what we just pushed. There it is. Save the trees, and it's building. Now we can verify this by creating a branch. We'll say git checkout branch lesson /23 limit Travis builds. And we'll go ahead and push this branch, specifying origin lesson 23. And that will get pushed as a new branch to our Git repository. And if we look at the build history here, we see that no longer will our lessons be built. And that is how you limit Travis from building any extra branches. And so now if we go to our repo and we'll refresh here, the build is now passing, and that is exactly what we want. And just to review things really quick, If we go to our Travis YAML, we simply add this branches property. We whitelist our master branch, and anything else that doesn't match this or a regex in this place will be built. And that is how you limit Travis from building extra branches. So far, we've only really considered Node as a consuming platform for our module, but there could be people who really want to use our library in the browser. And right now, with the way that we distribute our file, we're depending on require, which is common.js, which the browser does not support. And so we're going to add support for using our module in the browser. And we're going to use something that's called UMD, or Universal Module Definition. To do this, we're going to use a JavaScript bundler called Webpack, and we'll install that as a dev dependency. Next, we'll create a new file called webpack.config.babel.js. The .babel just allows us to write our Webpack configuration in ES6. So I'm going to go ahead and pre-fill this. So we are importing join from path. We have this include being dir name and source, and we're using that for includes on our loaders to run these loaders only on things inside of our source directory. And then we have our entry as the index file. Our output will be in the dist directory. Our library target will be UMD, Universal Module Definition, so it works in common.js, the browser, and AMD. And in the context of a browser, the library will be called Star Wars names, so you can get that off of the window object. And then we have the source map dev tool, so that we include source maps in our build. Now, because we're including the Babel loader and JSON loader, we'll need to install those. And now let's create our npm script for building these. We already have a build script. I'm going to rename this to build main because we're going to have 3 build scripts. The next build script is going to be build UMD, and then we'll have a third build umd.min. For build UMD, it will simply be webpack output file name index.umd.js, and it will be very similar for our min. The only difference will be we'll add a min here for the file name. We'll add the -p, which means run this in production mode, and that will tell Webpack to minify our code and optimize it for delivery to a browser. Now, if we run these scripts, we can run npm run build umd. And let's check out our dist. We now have this UMD file, and this is the Universal Module Definition function here. And it has all of our code in there. We even have our JSON directly in here as a module export, and everything will work just fine even in a browser. You'll notice also in this bundle that it includes the code for unique random array, and actually unique random array has dependencies and that code is included as well. This is probably just fine for a module like this one, but if you're building a plugin for React or Angular, then you'll probably not want to bundle the entire library in your small module. You'll want to adjust your Webpack configuration a little bit so that Webpack excludes those things from the bundle and instead requires those based off of the environment that it's in, whether it be global or common.js or AMD. And so that's something to definitely be aware of if you're building something that should sit alongside of another bigger library like React or Angular or Ember. Let's also go ahead and run our npm run build umd.min. And this will generate the minified version of this file optimized for delivery to a browser. Now we have 3 scripts that we need to make sure we run before we do any releasing of our library. So we're going to utilize a package called npm run all, which will help clean up our scripts a little bit. So we'll install this as a dependency. And with that installed, we'll add a build script that will utilize npm run all, and it will run these in parallel because they're not dependent on each other at all. And we'll run build : star. And so that will include build main, build umd, and build umd.min. So now we can run npm run build, and this, remember, will run our pre-build to remove the dist directory, and then it will run this build script to run all of these build scripts in parallel. So now we look at the dist directory, we have our index, we also have our Star Wars name still, so this can be consumed in a common.js scenario really easily. And then we have our UMD, so this can be consumed in a browser or in a common.js scenario or an AMD scenario. And then we have our UMD min, which is the same thing, just minified. And that is what we need to do to support the browser. So to review, there were a couple of things that we did. First, we installed Webpack, and then we created this Webpack configuration. Then we added JSON loader and Babel loader as our dependencies. We also created a couple of scripts here. We changed our current build to build main, and then we added build UMD and umd.min, and then we changed our build script to an npm run all script, which runs all of our builds in parallel. A final word about distribution. So we're not actually committing these generated files to Git, and so people can't go to our GitHub repo and download these UMD files. Instead, we can point people to npmcdn.com where they can get these files. We can see an example of that here. If you go to npmcdn.com, you'll see the example of React. And here they have the React min.js, and this is the entire React library. For our library, we could simply go to Star Wars-names, and this is going to preload us with the default, which currently can't be consumed by the browser. But when we actually publish this, people will be able to go to dist index.umd.js, and this will actually have the file that we're publishing to the registry. And that's how people will consume our package if they're using the UMD build.